This is Alan Elliott, and this is SAS Essentials, Mastering SAS for Data Analytics, 3rd edition. This is Chapter 4, Part 1, Preparing Data for Analysis. In this chapter, we'll be able to learn how to label variables with explanatory names, create new variables, use the if-then-else statement, use drop and keep statements, the set statement, proc sort, appending and merging datasets, proc format, and how to find the first and last values in a group. This is part 1 of 2 parts for chapter 4. Before you begin, make sure you've downloaded all of the necessary files if you want to follow along with the hands-on exercises, and they are at this address. Okay, let's get started. In Chapter 4, we're going to be looking at information mostly about the data step. And to recall, the typical SAS program flow is that you create or define a data set using the data step, and then procedures are used to do statistical analyses. And so this chapter is mostly about the data step, although we'll see a few procs along the way. Okay, let's look at section 4.1, Labeling Variables with Explanatory Names. So oftentimes when we create a variable, we use a simple name like var1, var2, or age or something like that. But we may want something more explanatory. For instance, we might want to say age in 2000, which means this is the age that we measured for a particular person in the year 2000. or something like that. We want to give it a more explanatory name. And we can do that with the label statement. And here is an example of what that looks like. So we have label, and then var1, whatever your variable name is, equal, and then in quotes, whatever label we want to assign to that variable. And then here we have var2 and whatever label we want to assign for it. Notice here in the label statement, we can assign as many labels as we want. When we're finished, then we put a semicolon to signify the end of the label statement. Now here's a program called dlabel1.sas that shows us how this works. So here I'm creating a data set called my data. I'm reading in data from a file called bpdata.dat, inputting several variables like ID, systolic blood pressure, DBP, gender, but I'm giving those labels. So ID means identification number, SBP means systolic blood pressure, and so on. So what this does is it allows us to create reports or output or some sort of printout with more explanation in it than the cryptic name that we used in the data set. So if I do a proc means, as we see down below, then the label statement is going to put those labels in my output. So here are 2 examples. The top example is if I didn't have the label statement, this is what my output would look like. So we see just the cryptic variable names. But then if I add the labels, I also keep the variable names, plus I have the label column, which gives me the more explanatory label. So that becomes very handy when you're creating some sort of output. And it's not just in proc print, but we're going to see it's going to be available in most, if not all, procedures. So let's look at hands-on example 4.1. In this example, open up the file called dlabel2.sas. And again, this is a data set that we're reading in. This one is going to have 3 pieces of information, F name, L name, and B date. And we can probably guess what those mean, but in this case, we're going to have a label statement where F name means first name, and then in a minute, we're going to complete all the labels. Now, when we print out this information using a proc print down below, notice we added the word label. In most procs, you don't have to tell it to use the labels, but in proc print you do. So we say proc print label. That means do a proc print, but also include the label in the output. All right, so if we complete the label statement with these 3 pieces of information, first name, last name, birth date, and then we run the program, this is what our output looks like. So we can see the column names are first name, last name, and birthday. If we had not done this, then our column names would be F name, L name, and B date. And so you can see this provides a much more readable output. Let's do another example, 4.2. In this case, open up the file called dlabel2.sas. In this case, we see that we're reading in only 3 records that consist of F name, L name, and B date. And we want to call those variables with a label, first name, and later on we're going to show how to add last name and birth date. And we read in that information, and then we do a proc print. Now the proc print requires that we have a additional piece of information, label. If we don't include the label option there, then when we do the proc print, we get the proc print without the labels. But if we include the label statement as shown here, then we get this kind of output. Notice it here where we have the output in the columns are first name, last name, and birth date. Now, we haven't really added those, but if you complete the label statement as shown at the top of this screen, and then run the program, you should get this output, showing how you can use those labels to, again, give you clearer and more readable output. All right, let's look at section 4.2, creating new variables. So oftentimes we read in data sets, but we want to create some new variable, often by calculation or something like that, from the data that's already in the data set. For instance, let's say we read in a data set with length and width, and we want to create area. We want to calculate area. So we could put this formula statement in the data step, area equal L times W, and we would create a new variable called area that contains that result of that multiplication. So you can do a lot of different kinds of arithmetic operations, and we're going to learn a lot more than this, but just as an example, the common ones, we have addition, subtraction, multiplication, division, and exponentiation. These are all the same that you use in things like Excel, except for the exponentiation. In Excel, you use a little caret, but in SAS, you use an asterisk asterisk. As you can see, qubit, x asterisk asterisk 3, so x to the third power. Now you may remember the following mnemonic from math class. It always comes in handy. Please excuse my dear Aunt Sally. And that has to do with the order in which the operations are going to take place. So you can see parentheses, then exponents, then multiplication and division, and then addition and subtraction. So that's a handy way to remember this. All right, let's do example 4.2. Open up the file called dcalc.sas, and in this example, we're going to create a new variable like we've seen, like we mentioned earlier. So we're going to read in a room size, and we're going to read in the width and length of each room. And what we want is the area in that room. First of all, notice we're giving labels to L and W, length and width, and then area is in square feet. And then we read in the data. I don't have it all there, but you read in all the data. And then in the proc print statement, we're going to include that label option so that it will print out the labels. We're also adding another option. We haven't really talked about it yet, and we'll talk about it more when we discuss proc print. But the sum area is another option that we're going to, or another statement that we're going to include in here to give us a sum of all the area calculations we've made. All right, so let's look at, if we've run that code, we see that we get this output where you have what we read in was room, width, and length. And then we calculated square feet. So you can see the square feet there of each room. And then at the bottom, 2146 is the sum that we asked for in the proc print statement. So that comes in handy sometimes. We're going to learn more about proc print later on and other things you can add to the printout to give you a better report. Also want to talk about the placement of this calculation. Notice how the area calculation is within the data step. The data step starts with the word data and continues until the run. So, and actually it needs to be before the data lines which is the actual reading in of the data. So here we have this area calculation is within the data step. You can't put it outside. It has to be within a data step. So just make sure that you put it in the right place. Otherwise, SAS will ignore it or give you an error message. Now, let's add one more thing. Suppose the ceilings are 8 foot tall and you want to calculate the total living area. Maybe you need that for air conditioning purposes, for instance. Now we can calculate volume. Volume equal width times 8 feet to the code. So we could add that statement, and now we'd have a new variable called VOL that then we could add up or whatever we want to do with it. So here's an example of that code. Notice the vol calculation I put right after the area calculation. And then we also added VOL equal volume in the label statement. And so now when we run the program, we see we also get a column called volume. Now we can also create new variables as constant values. So a lot of times we may have a constant value. Probably the most well-known one is pi, 3.1415, etc. And so we may need to have pi in order to create or to calculate other things like the area or circumference of a circle. So I can just have a statement in here, pi equal the value, and then once I have created that as a new variable pi, then I can use that variable in other calculations as we move forward. So area equal pi times radius squared, circumference equal 2 times pi times radius. And you can see again, if you run this program, you get radius, pi, and then the area and circumference calculated. Another handy thing within the data step is the if-then-else construct or conditional statement. And it takes this form: if expression, then statement, else some other statement. So it means, like in English we could say, if it's raining outside, then take an umbrella. Else, don't take the umbrella. Something like that. Thus, we could say in SAS terminology, if systolic blood pressure is greater than or equal to 140, then create a new variable called high BP, high blood pressure, equal 1, else high blood pressure equals 0. Oftentimes we use 1 and 0 to mean yes and no. So in this case, high blood pressure equal 1, we're going to code as yes, that is, the person has high blood pressure, or 0, the person doesn't have high blood pressure. So if their systolic blood pressure is greater than or equal to 140, we're going to call them high blood pressure. Else, if it's lower than that, we're going to call it not high blood pressure. Now, here are some conditional operators. We looked at the arithmetic operators. These are conditional operators we can use in these kinds of statements. And there's really two ways we can use it. We can either use the symbol, which we often use in mathematics or in Excel, or a mnemonic. For instance, the equal sign. We can use the equal sign, or we can use EQ. They both will mean the same thing. So at the far right it says I equal 5, or I could have I space EQ space 5. It would be the same kind of conditional operator. So here's an example at the bottom. If systolic blood pressure, GE, what does that mean? Greater than or equal to. Then high blood pressure equal 1, etc. We've seen that before. So that's where that GE came in. There's also some logical operators we can use: the and, the vertical bar, the caret, and the tilde sign. And they have various meanings. The and sign means and, the vertical bar means or, and the caret or squiggle means, tilde means not. So if age greater than 19 and gender equal M, then group equal 1, we could also use that vertical bar in a similar one. If treatment equal A, vertical bar means or, group equal 2, then category equal green. Here's a slightly more complex use of the operators, and we're adding something called an else if statement. So if treatment is A, then I'm going to say group is 1. Else, if treatment is B or treatment equals C, then group equals 2. Else, group equals 3. So here we have 3 different conditions to place people into various groups. If their treatment is coded as A, then they're going to be in group 1. If their treatment is coded as B or C, then they're going to be assigned to group 2. Otherwise, if they're neither A, B, or C, they're assigned to group C. So this else if comes in handy too. Now notice where the semicolon is. If treatment equal A, then group equal 1, semicolon, one statement. Then we add to it, else if, etc., semicolon, and then else. So each of these statements has a semicolon assigned to it. So let's look at example 4.3. Open the program called decondition.sas. And in this case, let's look at this data where we're reading in my data, inputting several variables, and we have the statement, if systolic blood pressure greater than or equal 140, etc. In this case, we're going to call it status equal high, else status equal okay. We're looking for people to identify them as maybe high risk, high blood pressure, etc. So we run that program, and notice here we have a new column called status, and we can quickly identify that ID 3 and 4 have high blood pressure. Now we can add to that statement a little bit by saying if age greater than 65, then group equals senior, else if age greater than 18 and age less than or equal to 65, then group equal adult, else group equal youth. So here we have three different kinds of, again, we're separating this into three different groups. If someone his age is greater than 65, we're going to call them a senior. Otherwise, if they're greater than or equal to 18, but less than or equal to 65, we're just going to call them adult. Otherwise, and the otherwise would be that they're 18 or younger, or I'm sorry, less than 18, then they're going to be categorized as youth. And if we put that into a program, we'll notice then we get a group variable. We still have the status variable over there, but we get a group variable now, youth, adult, senior, and so forth, that has been calculated from the age variable. Now we can also use if to assign missing values. Now missing values are a very important part of data sets that you may not really have ever heard of, but a lot of times, in fact most of the time, when data have been collected, some data values are not available, and therefore we're going to call them missing values. Now if you create an Excel file, a lot of people just put a blank if they don't know the value. Well, the problem with that is we don't know what that blank means. Does it mean we just didn't know the value? Does it mean that they wouldn't tell us the value? And so better is to put a code in that, not just a blank, but some sort of code. Let's say a -9 means that they didn't tell us, or something like that, or it wasn't available in their record, whatever it means. So now I can say if a -9 now is the value in an age column, then I can say if age equal -9, then age equal dot. That assigns the missing value dot, which is the SAS missing value code, to age. Or for instance, if we ask for someone's gender and they will not give us a gender, maybe we then code that as X. Then in our code we say if gender equal X, then gender equal, and that quote means blank, so that is a missing value. Again, two ways that we could assign a missing value within a data set. And again, you're going to see this again and again if you begin working with data sets from particularly any kind of data set that is collected from humans or some sort of biological event, because oftentimes you don't get the values that you want, and so you have some missing pieces of data. So let's look at this example, this if statement. Now this if statement looks like it might be okay, but there's something going wrong here. So let's just carefully look at this. You got to be careful with these if statements to make sure you cover all your bases. In this case, we're reading in age, and we say if age is greater than 12 and age is less than 20, then we're going to call this person a teen, teen equals 1, else teen equals 0. Now that works fine as long as we don't have missing values. Remember I said that a lot of times you're going to have missing values. You need to make sure that those missing values are accounted for. So when we run this program, what are we going to get in that teen column? We're going to get 0 for the first one. That's not a teen. 2 is not a teen. 3, 19, that's a teen. But look at 4. 4 is a missing value, but it is categorized as a 0, which means it's not a teen. But we don't know. We don't know that. So it's an incorrect assumption there. So we need to take care of that information. And the way you do that is you add a second if statement. And that is you say if age is dot, or missing, then teen is missing. So what we're saying is if we don't know age, we can't assign a value to teen, and so we're going to call it also missing. So you just have to be very careful when you're using these if-then-else statements. If you're trying to cover all your bases, make sure you also cover the category of a missing value. All right, let's look at hands-on example 4.4. In this case, open the file called demissing.sas. And we're going to look at a better way to create these teen categories. So we're going to input all this information, including age. And now we say if age equal 12, then age equal 20. And so now we have included the statement that includes the missing value. So do this example. I mean, it's the one we just looked at, but it continues on after this. So I would do this example from the text and follow along all of the steps that are in the text to get more information. Okay, let's look at 4.3.2, using if and if-then to subset databases. So if and if-then can assign new values, but it also can do something else. It can subset a database, and a lot of times people call this if expression a subsetting if. And notice here what it says at the very bottom, if expression, that's all. It doesn't say to assign anything, it's just if expression. So what it does is it tells to SAS if the data passes whatever expression we have there as true, then keep that data. Otherwise, don't keep that data in the data set you're creating. We'll see that as we go along here. For example, to select records containing the value F for females from a data set, you could use this statement, if gender equal F. So as SAS is reading in this data, it's going to read in the variable gender, and it's going to look at the value. If the value is F, it will keep that piece of data, that record. If the value is not F, then it won't keep that data. And so what you've done is you've subsetted the data set and ended up with only a data set with gender equal F, or females. You could do sort of the opposite by saying then delete. If expression, then delete. For instance, a similar one, if you only had M's and F's in your data set, if you say gender equal M, then delete, it would be the same thing as saying if gender equal F. Now, if you have other values, then that wouldn't work, but this shows you that you can use this then delete option as well. All right, now let's do hands-on example 4.5. Open the program called d_subset1.sas, and you see it here on the screen. Notice it has this subsetting if statement, if age less than or equal to 10. If we run this program, note that 22 subjects are included where ages are less than or equal to 10. Now, I think there's 50 in the actual data set, but this subsets the data set, so we end up with only 22 records. When you run it, you should see how that happens. So and then we could continue with the if expression then delete by saying if group equal A, then delete. So let's try that one out. If we use that if statement and then run the program, and here's the output, you see that the observation 1 is B instead of, there's no A in the group, so it left off all the A subjects in the listing. So again, you can either use the if statement directly, if expression, or if expression, then delete. All right, section 4.3.3, using if, then, and do for a program control. So lots of ways we can use if. Another way to use if is to control the flow of the SAS program with a do statement. In this case, we can cause a group of SAS commands to be conditionally executed by using the following type of code. So let's look at that. If expression, then do. So that says if the expression is true, whatever we put in there, then go ahead with the next few lines of code, whatever that is, and then it ends with end. So we can see that anything between the then do and end is code that will be executed if the expression is true. If that expression is not true, then it skips that code. Here's an example of that. If age is greater than 19, then do. So a lot of times when you're calculating BMI, you calculate it differently for different ages. So in this case, if people are less than 19 years or greater than 19 years old, the BMI calculation is the weight in pounds divided by the height in inches squared times 703. And we also are going to classify that as the same time. That's an adult, and we're going to include them in the study yes. So see, we've done three things here. After the do statement, we've done three different things. First of all, we calculated BMI. We've set this value as 1 for is adult, so we've signified this is adult because they're greater than 19 years old, and we're going to include them in the study equals yes. All right, so now let's look at using an at statement to conditionally read lines in a data set. This is a very clever and handy thing to learn how to use. So for big data sets, it's often the case you don't want to read in all of the data. I mean, you may have hundreds or thousands of variables or records or various things within the data set. You don't want to read in, nowadays data sets can have millions, even billions of records. Oftentimes, as you're reading through the data set, you want to limit the pieces of data that you use so you don't end up with a data set that fills up your entire hard drive or cloud drive or whatever. So let's look at this, how this statement works. It says if input group character 5, then input age in column 6 through 9, and then at. Well, what does that at do? It's not at. Remember we had at which said continue on. No, an at means stop. So what it does is it stops, and then it looks at the next statement. If group is equal to age and age greater than 10. See, we've already read in group and age, so now we can use that information to decide whether to input additional pieces of information. So if the group is A and the age is greater than or equal to 10, then go ahead and read some more information. In this case, read the ID number. We don't have to input group and age again, but we did there. And then time 2. So you can see here how that is going to conditionally read in pieces of information, which you gather from reading a little bit of information, and then use that little bit of information to decide what other information you may want to read. A very common one that I've used in the past in clinical situations would be in a study that was looking at pregnancies, and so if you read in and a gender is male, you probably don't want to go ahead, continue on to read information about pregnancy. Okay, let's look at hands-on example 4.6. In this case, open up the file called d_subset2.sas, and this shows you this conditional read. And so if group equal A, age equal 10, so forth and so on. So this is going to show you ways of doing this conditional read. Then input these other variables. So read that program file in, run it, and actually see if it works. And then you're going to change the if statement as indicated in the hands-on example to see some other ways of using this. So go ahead and complete this example using the steps in the text. All right, let's look at section 4.4, using the drop and keep statement to select variables. So oftentimes, again, I mentioned that we oftentimes read in, or maybe somebody sends us a data set with hundreds or thousands of variables in it, but we don't want all those variables. So a lot of the variables may be useless to us. And so we want to have a data set that only contains the information we need. So one way to do that is to use the drop or keep statement. For instance, the drop statement allows you to drop variables you don't want. The keep statement allows you to specify which variables to keep. So in this simple example here, I'm reading in a data set called my data, and I'm inputting A, B, C, D, E, F, G. Those are variable names. And maybe I have to do that because this is the free-form format. So remember, I have to read in all the variables in free-form format. So I have to read in F and G, but then I drop them because I don't want the resulting database. I don't need E and F in the database, so I go ahead and drop them at this point. And so they don't appear in my final data set. And this is an example that shows that, example 4.7. Open the program called dkeep.sas, and you'll notice here that I'm reading in some data. And in this case, I'm reading in, I don't know, 5 or 6 variables, but I'm only keeping age, time 1, and socio. So again, open up this database or this program file, run this, and see how this works. See what the resulting view of the data you get. And then play around with the keep statement to show that you can keep whichever ones you want. All right, in this case, notice we ended up with only age, time 1, and socio. Now, just for the heck of it, change that to group, age, and socio, and rerun it. And in this case, you should see that those are the variables then that are in your output. And there it is, where I've dropped group, age, and socio, and so all I have left are the time variables. All right, now let's look at drop, keep, and rename in the data statement. So this is a clever and interesting way that we can also manipulate a data set as we're creating it. So here I have data, my data, and then within parentheses I have rename equal socio equal status and drop time 1 dash time 4. That means time 1 through time 4. I read in the data using an in-file statement. And notice I'm reading in group, age, time 1, time 2, time 3, time 4, and time and socio. But what I'm doing here is I don't like the variable called socio. I want to call it status instead. So that rename statement, when I look at my resulting file called my data, I don't have a socio column. Instead, I have a column called status. So I've renamed it within as I was reading in the data. And again, there's some additional exercises on this that we can do. All right, there's your resulting information. Notice you have a column called status. All right, well, that's the end of part 1. We're going to continue with chapter 4, part 2, and look at these additional pieces of SAS code within the data step as we move along. So again, this is SAS Essentials. Thanks for watching. I hope this is helpful to you. If it is, please subscribe to our channel and like. Thanks for watching.